Imagine standing in a completely dark room. You can't see anything. You can't see your hand in front of your face. Then someone hands you a telescope. You point it up and see stars, billions of them. And here's what keeps you awake at night. They're not just up there anymore. They're moving, not toward us, away from us, and they're speeding up. That's the mystery we're talking about today. Something invisible is pushing the universe apart from the inside, and we still don't know what it is. Let me start with how we even figured this out. A long time ago, around 100 years back, scientists thought the universe was stable, fixed, like a painting that never changes. Then a man named Edwin Hubble pointed a telescope at some distant galaxies and noticed something strange. They were moving, and the farther away they were, the faster they moved away from us. It was like someone threw a stone into a pond. The ripples spread outward. The universe was expanding. That made sense at the time. If the universe exploded into existence at the beginning, then sure, everything would be spreading apart. But the big assumption was that gravity would slow it down. Think of throwing a ball up in the air. It goes up, it slows down, eventually it falls back. Scientists thought the same thing should happen to the universe. The universe expands at first, but gravity pulls everything back together. Eventually, either the universe stops expanding and collapses back in, or it expands forever, but at a slower and slower speed. Either way, something was supposed to slow it down. Then in 1998, astronomers made a discovery that broke everything they thought they knew. They were studying supernovae. These are massive explosions of stars that are incredibly bright. So bright that we can see them from billions of light years away. The astronomers were using them as measuring tools. They were measuring how far away these explosions were and how fast the universe was expanding in the past. They expected to find that the expansion was slowing down. That's what gravity should do. But the data showed the opposite. The universe isn't slowing down, it's speeding up. Imagine throwing that ball up again. It goes up faster. It keeps accelerating. That shouldn't happen unless something is pushing it from below. That's what the universe is doing. It's accelerating outward, and there's nothing we can see causing it. Scientists called it dark energy, not because they knew what it was, but because it was dark, invisible, and it had energy. The word dark just meant we couldn't see it. It meant we didn't understand it. And that's still true today. We now know that about 70% of the universe is made of this stuff. 70%. And we have no idea what it is. It's not matter. We can't touch it. It's not light. We can't see it. It's not energy like heat or radiation. It doesn't interact with anything we know how to measure. Except for one thing. It's pulling the universe apart. Here's what that means for your future. Right now, the galaxies in the universe are moving away from each other. They're so far apart that light from one galaxy takes billions of years to reach another. But in the future, they'll be even farther apart, and so far apart that light from distant galaxies will never reach us. In trillions of years, any civilization that exists will look up at the night sky and see nothing but their own galaxy. They'll look up and think they're alone in the universe. They won't know about the billions of other galaxies because the light from those galaxies will never reach them. It will have red shifted completely outside the visible spectrum and into nothing. The universe is slowly disappearing. But that's the future. Right now, we're trying to understand what dark energy actually is. And scientists have some ideas. One idea is that empty space isn't really empty. It has energy. It has potential. And that potential is stretching the universe apart. Another idea is that gravity itself works differently on the largest scales. Maybe Albert Einstein's equations, which describe gravity perfectly on small scales, break down when you look at the entire universe. Another idea is that dark energy is getting stronger over time, that the acceleration is actually accelerating. There's even a wilder idea. What if dark energy is the universe's way of tearing itself apart? What if the expansion becomes so violent that eventually not just galaxies but stars, planets, atoms themselves get ripped apart? Scientists call it the Big Rip, and while we don't know if it happens, we can't rule it out yet. The crazy part is that we're discovering this is happening, but we can't see it happening. We can't see dark energy directly. We can't touch it. We can't detect it with any instrument we built. All we can do is measure the effects. We can measure how fast distant galaxies are moving away. We can measure how that speed has changed over billions of years. And from those measurements, we can calculate that something is there, something that makes up most of the universe. And it's invisible. Think about that for a moment. We live in a universe where most of the stuff, most of what exists is invisible, and we don't understand it. It's like waking up in a house and realizing that 70% of the walls are made of something you can't see and you don't understand how it works. You live there, but you don't know what your house is made of. That's where we are. We're living in a universe made mostly of something we don't understand, and the more we study it, the weirder it gets. Some of the latest observations suggest that dark energy might not be constant. It might have been different in the past. It might be different in the future. It might not be the same everywhere. Dark energy is becoming a bigger mystery every time we measure it more carefully. The best part? There's no way to study dark energy directly for the next several hundred years. We can't reach it. We can't sample it. We can't bring it into a laboratory. All we can do is observe how the universe expands and work backward to figure out what's pushing it. We can build better telescopes. We can measure more galaxies. We can try to understand the physics better. But the core mystery, what dark energy actually is, that might take centuries to solve. And maybe that's okay. Maybe it's okay that there are still huge mysteries in science. Maybe it's good that we live in a universe that still surprises us, that still challenges what we think we know. Because right now, 70% of existence is a question. 70% of reality is something we don't understand. And somewhere it's still pushing us apart.